Hello, students. Today is Lab Day, and we are going to be exploring some of the properties of atomic bonds. And in particular, we're going to be comparing a certain characteristic that exists between ionically bound compounds and covalently bound compounds. More on that in a moment. But first, I want to introduce you to a tool that I created. I have a little homemade device here, which I call the conductivity meter. This is my conductivity meter. You will see that it is a power source connected to wires going through an electrical resistor here and hooked up to a little LED light, a little red light, kind of like Rudolph's red nose. And at the end, it's not an antenna. It's not like a little walkie-talkie. Come on in, breaker 19. Breaker 19, what's your 1020? It's not a radio at all. But rather, these two wires that come off to the top, and I'll try and show you as clearly as I can, are not connected. This is like an open switch. A switch which will become closed if electrons are able to flow from one of these wires to the other wires. Now, we're not going to connect the wires, but we are going to connect each of the wires or contact each of these wires to a substance. And if the substance allows electrons to flow through them, we know that electricity is the flow of electrons. So if a flow of electrons is allowed to go from one wire to the other, I have this device configured in such a way that the light will go on. Now we know that metals are held together with a metallic bond, and metals have electrons found in a sea of electrons able to surf from one nucleus to another. So electrons are free to flow through metals. That's what makes metals good conductors of not only heat, but electricity. So if I hold our conductivity meter onto a piece of metal, like my handy dandy Jeep Grand Cherokee from 1997, which still works and runs. I still ride it every day, but it's made out of metal. And so if I touch the conductivity meter to the key, let's see what happens. Ooh, ooh. Can you see what happens? Now, depending upon how the light is shining, I'll try and make it obvious here. Can you see that when the conductivity meter comes in contact with the metal, that light goes on? No contact? Contact. Contact. Start your engines. When the red light goes on, that means electrons are free to flow from one wire to another, basically completing the circuit. And by the way, my finger doesn't complete the circuit, but I have a ring on, a metal ring. Let's see what happens if I touch. Oh, look at that. I can touch the conductivity to my wedding band, and what do you know? Gold, being a metal, conducts electricity and the light goes on. So this is my homemade conductivity tester. If the light goes on, electrons are free to flow, and we can say that it conducts electricity. So we're going to be using this in the laboratory. But before we get to the laboratory, let me just show you one more thing here. We're going to go to the PowerPoint, and I just want to refresh your memory that we are working on the Atomic Bond Lab. So if you turn to page 126 in your book, I would like you to make sure that you write down these chemical formulas for the various solutions that we're going to be using in the lab. So the first solution we're going to be using is glucose, which is a type of sugar. And you can see the chemical formula is C6H12O6. The second one is glycerol, and glycerol is it can be used in a lot of like hand care products and shampoos and stuff like that. And its chemical formula is C3H8O3. Next, we've got silver nitrate, which is abbreviated AgNO3. Number 4 is sodium chloride, NaCl. Number 5 is distilled water. Distilled water has nothing in it but water, H2O. And finally, vegetable oil, C18H34O2. If you need more time writing down these chemical formulas, feel free to pause now. Now that we're back, I want to review a couple things before you even write your hypothesis. So let's just talk a little bit about bonds again. We've learned about the 3 types of bonds this week: metallic bonds, ionic bonds, and covalent bonds. We know that metallic bonds conduct electricity well. We know that. But what about covalent or ionic bonds? Do you think they conduct electricity as well? Well, let's just talk a little bit more about these 2 types of bonds in the context of our lab activity. First, covalent bonds. Covalent bonds typically are formed between 2 or more elements which are all non-metals. So covalent bonds are between non-metals, whereas substances, compounds which are held together with ionic bonds are generally speaking between a metal and a non-metal. And what I'd like you to do before you begin is think about the substances we're going to be using here. I just went over that list with you, and I'm going to show it to you again and give you a little advice. I want you to look at these chemical formulas. Look at the elements that make up these chemical formulas, and then look at your periodic table from last week's topic. And as you do, consider the type of elements that you have here. Are they metals or are they non-metals? And remember how you can tell the difference by looking at the periodic table. Find that staircase. The metals are to the left of that staircase and the non-metals are to the right. So as you think about what kinds of elements these compounds are made up of, you should be able to write down the type of bond in your observations data table based on the chemical formulas. Are these substances, or which of these substances, are held together with an ionic bond and which are held together with a covalent bond? Take a moment and try to figure that out and write your prediction of what type of bond each of these chemical solutions are contain. And if you need to pause the video, now's a good time to do so. All right, we're back. We're back in our virtual laboratory here today, and I have my conductivity meter, our conductivity tester, and we'll be using this throughout the lab. And I also have what's called a microplate. A microplate in this case, is a little porcelain dish with little reservoirs built into them. Now, I know the lighting here doesn't really enable you to see it, but I think if I hold my hand over to create a little shadow, you can see that there are 6 different little reservoirs here. They're just indented areas, and I have them numbered 1 through 6. I think the shadow enables you to see them very well. And they are numbered according to the numbers in your lab book. Number 1, I have a small amount of a glucose solution. Glucose is a type of sugar. You've all sprinkled sugar on your food, and perhaps you've taken a spoonful of sugar to help the medicine go down in the most delightful way. But glucose is sugar. So you can see the chemical formula right in your book as you wrote it earlier. Number 2, and by the way, I just dissolved some of that sugar into water and squirted some into reservoir number 1. Number 2 is filled with some glycerol. Glycerol or glycerin is a substance that is a lubricant. It can be used, it's often used in various products like dry skin and maybe shampoo and making your skin soft and supple. I don't really use it, but it's a valuable aid for chapped skin, glycerin. So that's in number 2. Number 3 reservoir has some of this in it. It's called silver nitrate solution. Now, you probably never have heard of silver nitrate solution, but some of you may have experienced it. If you've ever been to a dentist or a doctor and you've had a mouth boo-boo, it's possible that maybe the doctor put a long Q-tip in a brown bottle like this and then put it on your boo-boo. And silver nitrate is kind of an interesting substance. It chemically cauterizes your flesh. What did I just say? Let me tell you again. It melts your blood vessels closed. Yes, you heard me correctly. If you've got a boo-boo and you're bleeding, it's because your blood vessels are open, like an open hose, and blood is squirting through it. You've got to somehow, to stop the bleeding, squeeze those vessels back together again or close them, shut them off somehow. So instead of shutting your heart down and preventing the blood flow throughout your whole body, doctors will sometimes use silver nitrate. Silver nitrate chemically melts your flesh together to close the boo-boo. It's also used in another area that you are more than likely too young to ever recall, but when I was younger, even not that much younger, I used to dabble in photography. Now, I was interested in photography before digital photography, and I used to develop my own film with chemicals to make black and white prints. Silver nitrate can be used in that process, and old-time photographers, sometimes you could tell if someone was an old-time photographer and they had a dark room and they did their own chemical developing, because silver nitrate stains your skin black because it's melting your flesh. But old photographers had like black stains on their fingers from working with it. All right, moving right along to, that was number 3. Number 4. Here's a big bottle of it. You probably have much smaller bottles of this at home. Sodium chloride, aka salt. So we know about salt. In fact, you need a certain amount of salt in your diet. Too much salt isn't a good thing, but a little bit of salt is important. You need to have a certain amount of salt and this next item in every cell of your body in order for the chemical reactions to take place. All right, that brings us to number 5. Number 5 is distilled water. Now, distilled water, as I mentioned before, is just water. If you do your own laundry and ironing, maybe you have used distilled water in your iron, because distilled water has no minerals in it at all. We can't do this experiment with just tap water, because tap water that you get out of your sink, at least in this township, is very hard water. It has a lot of minerals in it, which can interfere with the accuracy of this lab. Distilled water, nothing but just water, H2O, and that's it. And finally, our last reservoir has a little bit of this, vegetable oil. And so there's a little bit of vegetable oil, and you know the chemical formula for vegetable oil. And you know, I'm sure you know what this is used for cooking, frying, and stuff in the kitchen. Yummy, yummy stuff. All right, so now you know the substances we're dealing with. You know the formulas. Hopefully by now you have written down what type of bond you think each of these substances is held together with. And before I show you the observations, I just want to remind you one last time, make sure you've written your hypothesis. What do you think? The question is electrical conductivity a characteristic of ionic or covalent compounds? Again, we know it is with metallic bonds, but what about ionic and covalent? Do you think one of them conducts electricity and the other doesn't? Do you think they both do? Do you think neither of them do? That's up to you to make a prediction before we do the experiment. So if you need to pause the video and write your hypothesis first, do that now. Otherwise, we're ready to go with the experiment. So let's get started. Now, I know the lighting here, again, is a little bit tricky. And so I'm going to add an audible sound. I'm going to go bzzz if I see the light go on. Hopefully you'll see the light go on, but in case you don't see the light go on, if it does, I'm going to go bzzz, because I'm not sure whether the camera will pick it up from this angle or not. And so what you're going to be doing as I put the conductivity meter into each of the 6 reservoirs, you're going to follow along and you're going to record the observation. Does it possess conductivity or does it not? Yes or no? Does it conduct electricity or does it not? If the light goes on, it does conduct electricity. If the light doesn't go on, it does not conduct electricity. So you can follow along in your lab book as we do this experiment. Are you ready? By the way, this is really a cool activity to do when the lights are all off in the lab and you can really see the light go on clearly. But for now, I'll just add the audio clue in case you don't see it yet. And by the way, after each dip, I'm going to decontaminate the wires so that it doesn't interfere with the next observation. So here we go. Number 1, glucose. Can you see that? Nothing is happening, no conductivity. So let me clean that off. Number 2, glycerol. Nothing. No light. So let me clean it off. Number 3 is the silver nitrate. Silver nitrate. Here we go. Can you see that? I don't know if you can see that or not. Maybe I'll hold my hand behind it. Can you see it? The light is illuminated, so I'll go bzz, bzz, bzz. The light is illuminated in reservoir number 3. Hopefully you could see that. So number 3, silver nitrate, conductivity. Clean this off again. Now we'll go to number 4. Number 4 is sodium chloride. Here's sodium chloride. Can you see that? Let me Hold that there, my hand. Can you see that? The light is coming on. The light is coming on. All right, so number 4, conductivity. Number 5, just distilled water. Here we go. Nothing. However, if it was hard water with minerals in it, depending upon what minerals were in it, you might actually see a little bit of illumination. By the way, the more it conducts, the brighter it is. All right, let's clean this off and get it ready for the last one. Number 6 is vegetable oil. Here is vegetable oil. Nothing. No illumination, no light, no conductivity. So there you have your observations. So we're going to head back over to the list. So you've got glucose, glycerol, silver nitrate, sodium chloride, distilled water, and vegetable oil. You've written down the type of bond, and in your book, you have the additional column for conductivity. Think about your observations. Think about whether it conducted electricity or not. Think about the type of bond. Answer your questions, write your conclusion, and when everyone is finished, we'll discuss this lab. So until we discuss, bye-bye.